All right, everyone, welcome to my first video with Screencastify. So hopefully you like my background, think like a proton, stay positive. I'm trying to figure this all out, so you're going to be patient with me. All right, so let's take a look at the nuclear decay worksheet. So if you're in my class, this is page 185 in your blue notebook. So we are going to work through some nuclear decay equations. And I am going to switch into tablet mode, so in my laptop. So let me hide this little thing over here. And yes, I'm switching to tablet mode. Okay, so I am going to take some notes. I'm going to work through these problems with you. And I'm feeling, since this is my first nuclear video, going with red, the first color of the rainbow. Okay, so the first thing we have to do is that when we do a nuclear equation, we have to make sure that the top numbers and the bottom numbers on both sides of the equation are equal. Because remember, the law of conservation states that matter, energy, and charge can neither be created nor destroyed. So our arrow is like an equal sign in a math equation, right? So if I have this 42 over here on the left-hand side, my right-hand side over here has to total up to 42. So what I like to do is I like to make three little boxes, and let me play around with that. So I like to make three boxes because I know I need to have a top number, a bottom number, and a symbol for a nuclear symbol. So we agreed that the top number was 42 on the left-hand side, the reactant side. So that means that my top number over here must also be a 42. And excuse my penmanship because my stylus doesn't work very well on the screen. So I'm using my itty bitty, like freezing cold fingers right now. So now I need to have the bottom numbers equal on both sides. But wait a minute, there's no bottom number over here. What do? I'm stuck. I can't finish. No, go to your handy dandy reference tables. So if I go to my handy dandy reference tables and I scroll down or up, whatever way you like to call it, I'm going to find my periodic table and I'm not going to rotate. Oh, maybe I'll play around with it. There we go. And I am going to find that the potassium has an atomic number of 19. So I'm going to use that as the bottom number of my nuclear equation down here. So the bottom number is 19. So then the bottom number on this side has to equal 19. So if I have a 19 on the left-hand side and a -1, careful for that -1, it trips kids up all the time. So I have to figure out what number plus -1 equals 19. You probably already figured it out right now. It's going to have to be a 20, right? Because a 20 plus the -1, right? That's 19 on this side and 19 on this side. So I'm almost done. All I have to do now is figure what the heck kind of symbol am I going to put in that box. Well, then I'm going to use this as my clue because that's always the atomic number. I'm going to use the periodic table as a secret decoder key, and I'm going to find out what secret symbol is atomic number 20. And ta-da, calcium right here, atomic number 20. Oh, right. So I'm just going to put that symbol there, calcium. And that's it. Done. I'm going to talk a little bit about this equation for just 1 second. Let's do a little bit of review on what's going on with this equation. This is a natural transmutation, right? Because there's only one reactant. So it means it's natural. But what kind of transmutation is this? Well, that's going to be, let's switch colors to blue. That means this is my clue as to what kind of natural transmutation this is. So I'm not sure what that is, but I think it looks familiar to something on my reference tables. Let's make that smaller. And let's flip. Hope I'm not making you dizzy. To table O. And here we go, table O. And look, there is that symbol. That's a beta particle. So if this is a beta particle, then this has to be what we call a beta decay. Okay, beta decay. Awesome. Easy peasy. Give me a thumbs up if it's easy. Give me a thumbs down if you have no idea what I'm saying. If you have no idea what I'm saying, you're just going to send us, Mrs. Mittigar or myself, a quick little email or a little post on that Google Classroom. All right, I'm going to erase this because it looks messy, bothering my OCD. And I'm going to move on to the next question. I'm going to move through the questions a little bit faster since I spent a lot of time on the first one. All right, oops. Sorry, kids. You know me and my technology. Now the eraser doesn't want to work. Okay. So I am going to go with orange, right? Let's change up our colors. Okay, so our next question is this plutonium here, and this producing this particle. This is a alpha particle. So then if it's an alpha particle being produced, it's alpha decay, Decay. All right, now all I got to do is I got to figure out my top number, my bottom number, and my symbol. Okay, so I have a 239 over here. I've got a 4 over here. So I need to figure out a number that goes here that's going to add up to 4, with 4, to add up to 239. So I hope you all agree. Either you have a calculator or you count on your fingers. This is going to be 235. Okay, so I've got the top number. Now, I don't have the bottom number, but again, I go to my reference tables. I go to the periodic table, and I find plutonium down there, right? Here's our plutonium, and that's going to be a 94. Okay, so I'm going to put a 94 over here. And now I need to figure out what number is going to be the bottom number. So what number here plus 2 is going to be equal to 94? That's going to be atomic number 92. And now I've got to go find, back on that periodic table, the secret decoder key. I'm going to figure out what symbol am I going to put with that 92. So back to the periodic table, and I'm going to figure out where number 92 is. Don't forget to look down here, guys. That's going to be uranium. Okay, so then there you go. Question number 2. All right, I want you to give question number 3 a try. So I want you to pause this video. I want you to try question number 3. And then I would like you to come back to the video and see if you got it right. It's okay, pause now. If you have no idea what you're doing, follow along, because I'm just going to do this one for you. Okay, so I have a top number, a bottom number, and a symbol. So now I have a 90 over here and I have a 92 over here. So then this number is going to have to be a 2, right? Because 90 plus 2 equals 92. Now my top number is 235 and my number over here is 231. What number plus 231 will add up to 235? Well, this is going to be a 4. So then I'm like, okay, now secret decoder key. I can find that on the periodic table. That is the element helium. Or I can also find this on table O, because that's an alpha particle. And so again, this is another alpha decay. All right, so now I'm going to go to our next problem, and I am going to choose, no, don't like that color, green. Okay, so again, we have the top number, the bottom number, and a symbol. So it's going to be a 2 over here. 1 and 1 is 2. And then 1 plus 3 equals 4. And then again, secret decoder key, table O or periodic table, He. Again, this is an alpha particle or a helium nucleus. And this is going to be an artificial transmutation. I'm not going to write the word transmutation. It's such a long word. Okay, so this is an artificial transmutation, and the reason I know this one's artificial is there's 2 reactants. This one up here is natural. There's only 1 reactant. Okay, moving on to the next question, right? Let's keep choosing different colors because that's fun for me. Top number, bottom number, symbol. 3 over here, 2 over here. What number is going to go on the bottom, kids? 1. All right, so wait, there we go. Now I've got a 6 over here and a 1. So then that's a total of 7 on this side. I have a 4 over here. What is the number that's going to be in my missing spot? That's going to be a number 3, right? Because I have 3 plus 4 and 3 is equal to 7. Secret decoder key, periodic table, tells me that atomic number 1 is H, hydrogen, right? This is an isotope of hydrogen. It has a different number of neutrons, right? This has 2 neutrons because 3 minus 1 is equal to 2. All right, switching up the colors again. All right, going to my next color. So then what is our top number, bottom number, and symbol going to be on this one? All right, so I've got aluminum and I've got phosphorus. And then this one is I've got my top number, my bottom number, and my symbol. All right, so I have a 27 plus 4 is equal to, okay, that's equal to 31. Good job. Did you count on your fingers? I did. All right, so I have 13 over here and 2 over here. So then it's a total of 15 on that side. All right, so I've got a 30 over here. So then what number plus this 30 is going to equal 31? 1. Okay, top number done. Now let's do the bottom number. I have a 15 here and a 15 here. Well, what number plus 15 is equal to 15? Are you thinking? And you're like, wait a minute, there's no what? It's kind of confusing, right? No, 0, right? 0 is always an option. Okay, so now I got to figure out using my secret decoder key, what the heck is that going to be with this 0 as the bottom number? Well, I checked my periodic table secret decoder key. Let's check. And let's just rotate. And too fast. Sorry, guys. Is there an atomic number 0? No. So what do? Well, we're going to go do the other, oh, making you dizzy. Okay, going to table O in our reference tables, right? Because we're using table O a lot in this unit. And which of these things has a bottom number of 0? Well, the bottom number of 0 is going to be our, oops, I want to make sure that I do this, our neutron. All right, back to our nuclear worksheet. So then I'm going to put a N over here. So then that's going to be a neutron, right? So this is artificial decay. All right, moving on. We're making such great progress, guys. Let's use this nice little, purple color here. So number 7, I'm going to tell you the answer. We've got a 6 and a 3, and that's going to be lithium. Does that make sense? Right? 9 plus 1 is what? Is equal to 10. And I already have a 4 over here. So 6 and 4 is 10. 4 and 1 is 5. 3 and 2 is 5. Check. Natural or artificial transmutation, guys? Which one? That's right, artificial, because I've got 2 reactants. Okay, so back over here, let's look at number 8. We're almost there. And let's switch colors again. Oh, let's do the yucky color. Okay, so here we have no bottom number. So then we better make sure that we give that a bottom number. So that's going to be 19 from the periodic table. So then what number is going to be our top number, our bottom number, and what symbol do we use? I have a positive 1 over here. So what number plus positive 1 equals 19? Good job. 18. Easy peasy, right? Top number is 37. Top number 0. What number plus 0 equals 37? That's right, 37. Now I just got to figure out what element has the symbol 18. So what does that go with? Scan the periodic table. There you go. That's going to be argon. So then what kind of decay is this? Is this artificial? Is it natural? Positron, beta decay, alpha decay, gamma radiation? Which one of these crazy things is it? Well, I have this over here. This is going to tell me the particle. That's going to tell me what kind of decay this is. There's only one reactant, so it's a natural decay. And then since this is a positron, we call this a positron emission or positron decay. All right, let's take a look at this last one. This one's a little bit tricky. Do you want to try it on your own first? Top number, bottom number, symbol. This would be a great place to pause your video and give this a chance. Okay, pause. Did you really pause? If you didn't pause and you're still confused, just follow along. Or if you know what you're doing, you can fast forward and you can just go right to my answer. Okay, all of these numbers on this side, 142, this whole 91, and this 1, right, all have to add up to this top number plus 1. Okay, don't forget that plus 1. Now, what does the coefficient of 3 mean? That means that it multiplies everything after. So then that means that's going to be a total of 3. And then 3 times 0 is still 0. So your bottom number will be 56 plus 36, right? And then that's going to be your bottom number over here. So then that is going to be 92. Okay? So then now I have 142 plus the 91 plus the 3. So then that is going to be equal to 236. I'm just going to jot that down over here. 236. So then this number over here has to add up to 236 with 1. So what number is that going to be? That's going to be 235, right? 235 plus 1 equals that 236. So next, secret decoder key periodic table tells me that this is the element uranium. Awesome. All right, give me a thumbs up. Not that I can see you, and I can't believe I've got one question left and my dogs haven't barked yet. All right, I'm going to give you the answer. 241, and then this is going to be a 94, and then this is atomic element number 94, which is Pu plutonium. All right, easy peasy. Give yourself a check plus if you made it this far with me, and I'm going to figure out now how I'm going to exit this video.